Hello guys, very welcome back. In this video we'll cover about the chemical composition of sedimentary rock. A chart of showing the sandstone with the yellow color, the shale with the dotted, the limestone green, and the laterite with the blue. Alright, laterite showing Al2O3 Fe2O3 H2O, limestone MgO, CaO and CO2. The shale in between this and sandstone is here. Now here you can see the average sandstone is somewhat here, below which is average igneous. The left of average igneous is average shale, and at the last having a significant amount of MgO and CaO and CO2 we have. Now first statement, the range in the chemical composition of sedimentary rock is much larger than the range in the chemical composition of igneous rocks. That means if you classify the sedimentary rocks, there would be more sedimentary rocks on this table and there would be lesser number of sedimentary rocks if classified in the table of igneous rocks. Alright. For example, the limestone from 55%, there can be various variations in this CaO composition, okay, calcium oxide composition. Why is this so? Apart from this composition, there are also many rocks. What is the reason for this? The reason is very simple: the weathering cycle. The weathering cycle now, consists of both the mechanical weathering and the chemical weathering. The mechanical weathering produces mechanical sediments, which are compositionally same as that of the parent material. That is, if an igneous rock and a sedimentary rock both are weathered mechanically, both will produce the fragments which are compositionally chemically same. But if igneous and sedimentary rock undergo chemical weathering, for example, there is some water, okay, and both of them undergo hydrolysis, both may undergo some changes, assume I2 and S2. Now, at one point of time, assume all the chemical constituents of igneous rock, fall in water. There will be some time, right? If they are constantly exposed to the chemical agents. And same for S3. Now this igneous, the elements will finally accumulate, or either they will precipitate or they will undergo with evaporation. They may either form the rock salt silvite in the form of evaporation, or in the form of precipitation they may form the gypsum, the rock anhydrite, the roadstone, etc. Agates, right, which are none other than the chemical sedimentary rocks. All the examples of sedimentary rock, and hence the range in sedimentary rocks is larger. Now let me name some of them. Now is the composition and the rocks and how they are formed. Now halite, alright, and silvite. When these are the composition in the water in the lake and the water evaporates, rock salt and rock silvite is formed. Fine. Again, if the rock has lot of sulfate, CaSO4 or anhydrite, they undergo precipitation, right? Same process as the water from the clouds fall. When the precipitation, when the concentration of water exceeds that of limit, it precipitates, forming rock gypsum and rock anhydrite. When magnesium is present in large amount, and the calcium along with magnesium form.
Alright, this video is going to be on the special properties of minerals. We're going to be comparing calcite to dolomite, and we're going to use a weak acid, hydrochloric acid, HCl. And first off, before we get started here, you'll see that both calcite and dolomite have what we call a rhombohedral crystal form, where they both take on this rhombus shape. However, calcite is going to effervesce. It's going to react with the HCl a little differently than the dolomite will. So we can test that, and we'll look at this here right now. So I'm going to zoom in pretty close, fairly close, and I want you to see the reaction that takes place with calcite. And this is what we would say is a vigorous effervescence, lots of bubbling. And that's not uncommon. That's an indicator that it's a positive indication that calcite mineral is present. You can see the bubbling. And it's a vigorous reaction. Whereas dolomite, we're only going to get a little bit of a reaction, just a real mild one. Let's see if I can zoom in on it. Where you at, zoom? And we just get this kind of uncommon and infrequent bubbling. A little bit, just not a lot. Well, now I can take and apply the concept of effervescence to calcite, to rocks that contain calcite. And here we have just pure limestone, and here I have fossiliferous limestone. And there are actual fossils in this particular rock here. So here I've got limestone and fossiliferous limestone. And to indicate that these both have calcite minerals composing them, we can drop acid on them. We'll see vigorous effervescence, and I can do that here as well. And you'll see the vigorous effervescence taking place, both of which contain calcite. Whereas when we go back to dolomite, here I can look at crystalline dolomite. Let me scooch this one over. And we'll see just a really mild effervescence here. And you'll have to look fairly closely. But it's happening. It's just a real mild effervescence. Real mild. So mild versus vigorous is an indicator of if it's calcite or dolomite when in the presence of a weak acid.
Dolostone, again with the precipitation. As far as the silicates are considered, silicates, they first of all they generally form in the groundwater under the some beddings. Again, they also undergo precipitation, formation of agates, geoids, concretions.
This is the mineral calcite. It's calcium carbonate, so it's not a silicate mineral. It tends to have some pretty simple characteristics that you can look for. Even if you have a broken piece like this one, typically it has enough crystal faces on it that you can see their arrangement, their geometry. These are slightly nicer crystals. They have 3 directions of cleavage, so the tabletop and my top hand, then one coming this way, then one behind and one towards the camera. So 3 cleavages, but if you notice, they're not at a right angle. So that's a really good characteristic. It's rhombohedral cleavage, very distinctive for calcite. Another one that you can do is by using just a drop of acid. You can put that on your sample and it will fizz as it releases carbon dioxide. Lastly, you can check the hardness, and the hardness of the calcite should be a little bit harder than your nail, so you should be able to scratch and leave a mark on your fingernail. So calcite, look for the rhombohedral cleavage, test it with acid. You don't want to confuse it with something like, say, halite, because the halite would be, of course, taste salty and have 3 directions at right angles. You wouldn't want to confuse it with quartz, but quartz is a lot harder. This would not scratch glass. Calcite.
Now the calcite with the mineral, it has the biological origin. When the biological origin of calcite is precipitated, it forms limestone. Okay. Now let me finally cover the chemical and the biochemical classification of the carbonates. The chemical are ullitic, interclast, and dolomite, which forms dolomstone. The biochemical are micrites, these are clay size, fossiliferous rocks, pilital rocks, chalk. Other chemical rocks are chert and rock salt, and other biochemical rocks are peat and coal. So that's all. Thank you.